Hi guys, welcome to Learn Electronics Repair. I have a power supply here. This is from an iMAC and I made a video with this power supply. It was quite interesting. We had to do some short circuit finding and it was really a popular video. So I've now ordered some parts which have arrived, so hopefully this will be a short part 2, fit the parts and it will work if we manage to find everything. I'll just remind you of where we were. So on this side of the board we had two short circuit diodes, like this one and this one. But when I say short circuit, they're actually not. Only one of them is short circuit. So if we go in diode mode, this reads open this way and the diode junction this way. So that one's okay. And this one is short. Okay, and they're both the same part. Now the one that reads okay came from here, and this actually reads short in circuit. So if we go across the actual two pads, that reads basically as a short. The other one came from here, which there is no short, and I actually marked there's a line across there. Probably if I catch the light on it, this is where the stripe on the component goes, so I know which way around it goes. Now this one is actually directly across these two current sensing resistors, so that's why this reads short. Basically we're just reading these low value resistors in parallel. So I could replace that one, but I've bought a pack of 5, so I may as well put the new ones in. So we'll replace these two diodes first, and then we had some more problems with the components on this heatsink. Here are our replacements. You can see SHJC, that's the same part number as the original one. Another one here, just a bit difficult to catch the light on it, but it is the same part number. Okay, it is revealing. So let's replace these first. I'll just clean up the tabs, the pads. Okay. Just adding a bit of fresh leaded solder on there. Make it easier to unsolder these. We'll rather get them nice and flat. Okay. That one done. The other two I think are fairly flat anyway. Yeah, looking good. The first one goes with a stripe downwards towards me. We can always test it just to be sure, since we have the meter turned anyway. Diode mode, so it should conduct in this direction. Yep, that's a good one. Now let's solder this one on and then the other one. I think if we put a bit of flux on here first, that will help it to stick down. Just position it on there, and then I'll hold it with tweezers. Just moved across a little bit because of the other one here. In fact, actually, you know, I think it's going to be easy to solder that one first because of the position of this one. Just seems more sensible to do it this way. This one has this stripe towards me again. You can see the mark on the board. We may as well just check it. Good one. It's quite often you can make things easy or difficult for yourself when you're doing this. Just think about it a little bit before you do it. And if you do it wrong, unsolder it and do it the right way around. Okay. Right. Let's try and get some solder on this. It may help with some hot air actually to warm the whole thing up, but let's see. Turn it a little bit so it's the easier angle to work from. So we can push it down. Yep, it's flat. Yep, nice and flat. Okay. Now we can get the other one. Yeah, that way around. Same sort of thing, solder on one end. Tweezers. Moved it before the solder had solidified. Okay, go a little bit more that direction. Okay, then we just push it flat. Okay, these are not too difficult to work with, guys. These are fairly chunky things. Main thing, good chunky soldering iron tip. Don't try to get enough heat into this with a fine tip, you will not do it. You might do it if you use a fine tip in hot air, but why make life difficult? Okay, let's clean that up and then we'll just check under the microscope, make sure we haven't bridged anything. Okay, I think the magnification is good enough on here. You can see that I haven't bridged anything there. That looks okay. Now let's get on to the components on the heatsink. So these go here. This is it. And it goes this way up. Now that makes it very difficult to work on. There's like a couple of pegs in here that go into the board. If you saw part one, you'll see this was quite difficult to desolder. In fact, if you're interested to know how I did it, go look at part one. There is also a little thermistor that sits under there as well and goes into this rubbery stuff here. And this goes like this. Now if we look at it, you'll see that this MOSFET and this diode are actually part of the PFC circuit, okay? Power factor correction. I'm on diode mode. The MOSFET is completely short. And this one, those two pins are connected together. And this actually reads like a diode, so those two pins are just connected to each other basically. So this reads good, but because this is short, it may have put stress on this, so I ordered one of these at the same time. The other two are the MOSFETs, which are part of the main switching circuit for the pulse width modulation for the power supply for the transformer. These are actually okay, so we can just use the component analyzer. N-channel MOSFET, okay, and the other one N-channel MOSFET, so they're okay. To make life easier, I'm going to straighten these legs out somewhat and just stick these components into the holes, okay? The two new ones, I'm just going to stick them into there, so I'm going to unscrew these off the here for now. unless I can actually do it with it balanced on there. I probably can actually, and just solder them in like so while we test it. Yeah, once it's tested, we can put it all back together on the heatsink. Okay, so I've soldered those in for now, just loosely, just making sure that these don't touch the capacitors behind them. Yeah, we can try this now. Obviously we can't run it under load. I just want to see if this actually powers up and gives any sort of output voltage. If it does, then I will put it together and we can give it a try. The mains comes in here on these two pins. It had like a board that fits across the top here, and the wires soldered on here. But I can just solder a couple of wires onto the back of these for now. Connect a power socket. We'll put the light bulb current limiter on, and let's see what it actually does. It looks like the output of the power supply is here, so these three pins are all connected together, and these three are all connected together, I think. Yeah, and these go through like some low value current sense resistors. So this is probably the ground, and then this is probably the voltage supply, and we don't have a short between them. That's just capacitors charging. Okay, so I'm fairly confident, but I could be wrong, that the ground is on the same side as the current limiting resistors, which suggests that this will be a ground. These three and these three will be the output. Yeah, so we can switch that to volts. I have the current limiter connected. Which would you like to see first? Current limiter, I guess. So that's up here. We're on limit. No, we're on limit now. Just switch the power off. Okay. We set to limit. Let's switch this on and see what it actually does. Whoa! Well, it did that, yeah. So it didn't like something, it actually blew up even with the current limiter on. But it wasn't drawing much current, you saw the light bulb had gone out. That's interesting. I wonder if the driver chip, which is powering the faulty components, actually is blown. I do have some spare ones and I do have some spare parts. But first of all, we need to have another look to see what's gone bang. Okay, so first of all, let's check if there's any high voltage in the capacitors. That is here and here, I think. Yeah, one is set further slightly back than the other one. So what's happened to it? Okay. Diode mode. So that diode's okay. This isn't short. How about the output devices? No. But something didn't like it. I'll take all these devices back off the board. That's the good thing about the fact I just tagged them on there. And then we can test all of these individually and see what's actually happened to this. And here they are. The two output devices, the diode, and what's left of the MOSFET. Let's have a look. Well, that's good. That's one of the MOSFETs. This is the other one. Okay, so they're okay. Here's the diode. Must get some batteries for this diode. And well, obviously this isn't going to test good, is it? So this is the gate, I'm sure. Drain, source, and there's nothing there. Okay, what else happened? What else happened? Well, most of the flash and the bang, if you like, seem to come from the other side of the board. I think I'll get us under the microscope and we'll see what we can see. This is probably the resistor that was between the gate and the source, I would say. I'll just have to check the pin out of this device. That reads like 2.5 meg, so I think that's actually gone. Then this W2T is either a transistor or a diode package. So have a look to see if we can see any readings on it. Well, there's a short there. So that one is gone, I would say. I'll clean this up a little bit with ISO and see if I can actually see the component markings a bit easier. Well, that might help a bit. This could be a diode or could be a capacitor. It reads open that way. Does it read open the other way as well? Yeah, that just reads open. Marked A6. Okay, this is a 270 ohm resistor, so this we can measure. May have to remove the possibly shorted device W2T first. Let's have a look. Well, that reads 11 meg, so that's open circuit, we can say. Just check the meters working. Yeah. So I think we can say that that is open circuit. This, we're not sure what it is. This one, I think I can see a marking on it. Looks like CO1. Let me have a look under the microscope itself. That looks like it could say 100 or it could say C01 or possibly E01. I'll have a look at those resistor codes. I think C01 we can have a look. This thing marked A6, I'm not sure about that one. Let's have a look what else we have here. This one, 4704, that's like, well, 470 and 4 zeros is 4.7 meg, I would say. It is about 3.2 meg, quite probably okay. This is some sort of startup circuit. 3 meg. They're probably all okay. Couple of capacitors. We shouldn't read short. Okay. Yeah, they're probably okay. So it looks like one resistor. This could be another capacitor, but I'm just thinking, why would you have a 270 ohm resistor in series with a capacitor? Well, that reads short. It probably isn't a capacitor. That may well just be a 0 ohm. But then why not just put the track there? And the drive for this looks like it comes from here. Okay, this 510 ohm resistor reads, not 510, I've done this again, 5-1 and no zeros, 51 ohm resistor reads okay. And that brings us back into this chip again. That one reads quite low, about 50 ohms. This is a bit of a strange value, but 870, so 87 ohm. Could well be. So there's a number of things we can't be sure what we have here, but you should be able to work this out. So if we have a look at this, we have this chip, NCP1605BG. That's the power factor correction controller, and that drives into this one, which would be the base if this is a transistor, or the gate, and then we have the drain and source or collector emitter, depending on what this thing is, and this resistor. Now the resistors from the base or gate down to the emitter or source, these are actually MOSFETs, so that's gate, drain, source, I'm pretty sure. And this resistor, which looks like CO1 or EO1, but I'm actually looking at it now and comparing with this circuit. So this circuit is powered by this chip, and this is a pulse width modulator for the main power supply, if you like, the actual switch mode power supply. Now we have two resistors here which are in basically the same position, yeah, from gate to source, and these are 103 or 10k, so I'm pretty sure that's actually a 10k resistor, just based on that, and I think I'm right. Okay, this device here, W2T, there's another one there and another one there. So if we can't find the data sheet, we can look that one up, or we can just remove one of these and see what they are, and that's probably the similar. This is a sequence of 4.7 meg resistors, all in series. That's some sort of startup supply which comes down into here, which will probably start this chip running in the first place to get the PFC going. It makes sense. This would have some sort of startup supply. Yeah, we have another sequence of high value resistors here that comes down also into this area. So I think that they're to do with startup. I can't think of any other particular reason why you would have those. Let's have a look around the devices in here. So this is another one of these A6 devices. This had open circuit on the other one. There's nothing on ohms range. It reads like a diode here, so we need to take that out and take that one out to see what they are, because they don't read the same. I mean, it could be something else in circuit we're reading. Okay. Another one of these W2T devices. We can have a look at this one. So if it's bipolar, and I don't think they are diode matrices because all three legs seem to be used. No junction there, go this way. Well, this one appears to be completely open. No, we have a diode junction there. But nothing there. This may be a MOSFET in actual fact. There's another one I've spotted over here. Let's look at this one, see how this one reads. Reads different again. Diode. Yeah, that reads like an NPN transistor, sorry, a PNP transistor. One more here, does this read the same? Yeah, that also reads the same. So those are like PNP transistors, which suggests that this one is actually faulty. We can say then that this one is short. It is definitely faulty. And the other ones look very much like PNP transistors. So this one is okay. I think we can actually find the part number for this one. Let's have a look on the internet. I've searched for SMD code W2T and I find pretty much straight away this one, PMBT4403. So that appears to be the actual part number. It is a transistor. It's in the correct package. So we can search for that one. And from there, we find the data sheet. And it's a PNP switching transistor. So all the evidence points to that being the correct one. And I'm sure I could get some of these. Another thing I'm thinking about this. I'm sure you noticed when I powered it up, the light bulb came on once and then went dim. So the main capacitors, the big smoothing capacitors, charged up. And then it sat there for a couple of seconds. The light bulb was practically off, so it wasn't drawing any power, and then it went bang. And one thing we do know is this transistor failed. And here is the original one that we had that was faulty. If we look at it, you can see the port number 6R199P, and then this little emblem to the left hand side. It's like a company emblem. That thing, the I in this little possibly backwards D-shaped thing, but that is the company emblem, okay? And the replacement I have is this one, and you can see it has kind of like the same emblem and the same part number, but I'm wondering if this one is a fake. Is this a case of fake MOSFETs from AliExpress? It's something I've never particularly experienced before, but that is not the same. But it's not that it's another manufacturer. It's kind of like it's being made to look like that one, but it isn't that one. I'm wondering, because this power supply is from an Apple, whether these were tended to be used a lot by Apple and maybe they're fakes, yeah? Because something caused this to blow up, and it blew up in rather a strange manner as well, to be quite honest. It turns out in the end then, maybe this probably wasn't the best PSU repair video on YouTube, but I think it was probably one of the most educational ones. I've just been speaking with Handy Andy about this, because the customer's coming in every day. And we had a look on eBay, and in the UK, we can buy a complete replacement working power supply from one of these model of iMAC for £25. So we're just going to get another one. Now, maybe we should have done that in the first place, or then maybe he should have looked. But he did say that the replacement ones are mainly in the UK. We're in the Canary Islands. However, it just so happens my wife is going there next week for 5 days, so we're going to order one and just get it posted to the address she's staying at, and she can bring it back with her. So we'll have to say you're not going to see this one again unless I decide out of interest, because I will keep this one. Maybe I'll decide, or you guys will decide, comments below, yeah, whether we should experiment a little bit more with it. If we do that, there's a couple of things that I've thought of. One is that this effectively is the PFC circuit. This is the switch mode power supply circuit, and these seem to be okay. So the way this basically works is you have, in our case, 220 volts AC coming in, and that would normally charge these capacitors to about 320 volts. That 320 volts DC then runs the switch mode power supply. But with the PFC, the MOSFET, the inductor that's involved with it, there's an inductor in here somewhere, and the diode, and there's the inductor, I'm pretty sure, form a voltage booster. That's what the PFC actually is. So this runs as high frequency and boosts the voltage in here to about 400 volts. and the 400 powers the main power supply, not the 320. And it's done for efficiency reasons, basically. It's a much more efficient power supply. But there's every reason to expect that if we just put this diode in and we leave the MOSFET out, that we'll then get 320 volts in here. And looking at the design I mentioned before, we have this chip is the PFC controller, and this chip is the pulse width modulator controller for the main power supply. And depending on the chips, we have data sheets. It may be that this will just run without the boost working. Maybe not at full efficiency, but prove that the power supply actually runs, or at least this part of it. It may be that it needs some sort of enable signal, like a power good coming from here to here. But if it does, I'm sure we can effectively not exactly bypass that, but force the power good so this will run. So there are ways we could go further with this. If that does work, then maybe find some other MOSFET. But I'm not going to make any money out of it, so it's a good question. Is it worth doing? Yeah, is it worth doing? I know you're going to say yes. Maybe somebody will then send me the bits as well. Yeah. But anyway, that's kind of the end of that one, guys. I hope you have enjoyed it. I hope you have learned some stuff, and I will see you all soon. Ciao for now, guys.